Hi everybody, I am back. This is Mr. Bogachnik again to continue our discussion about the universe. There's just so much to cover that I split it into two sections because, it's a pretty big universe. Okay, so how is planetary distance measured? Well, what we use is something called the astronomical unit. That's the average distance from the Earth to the Sun. An astronomical unit is about 93 million miles. If you prefer metric, it's about 150 million kilometers. So it's the distance between the Earth and the Sun. Now, a light year, as mentioned before, is the distance light travels in one Earth year. That's about 5.9 trillion miles, or about 64,000 astronomical units. Some different distances. From the Earth to the Moon, light will travel in about 1.3 seconds. From the Sun to the Earth, it takes a little over 8 minutes, which means if the Sun ever, for some reason, stopped shining, which it won't, not for billions of years, but if it ever did, it would take over 8 minutes for the last bit of light to get from the Sun to the Earth. Now, between the Sun and Neptune, one of the more distant planets, about 4 hours, and from the Sun to our closest star, it's 4.2 light years. So it takes light 4.2 years to get here. Now, if we skip all the way down to the from the Sun to the center of the Milky Way, 100,000 light years, and all the way across from the Milky Way galaxy to the nearest galaxy, which is Andromeda, is about 2.5 million light years. So it takes light 2.5 million years to get there. So where is our solar system located? It's located within the Milky Way galaxy. The Milky Way galaxy is about 100,000 light years in diameter, which is pretty big. We are orbiting in the Milky Way around its center bulge. So that's that bright spot in the center you can see in the top right picture. We orbit around that. It'll take about 250 million years to complete one revolution. And what is a galaxy? Well, it's a huge collection of stars, gas, and dust held together by gravity. We live in the Milky Way galaxy. It is a lot of stars, and a lot of gas, and a lot of dust. So, what type of galaxy is the Milky Way galaxy? Well, it is considered a spiral galaxy. A spiral galaxy is the one in the middle. An elliptical one would be like a big glowing kind of area with stuff all the way around it, and irregular is just kind of stuff all over the place. We are in a spiral one, so it looks like it's flat, and it looks like a spiral type shape. Okay. So the Milky Way, the diameter is about 100,000 light years across, and there is what we think a supermassive black hole in the center. So on the left-hand picture, that's viewed from above, and on the right-hand picture, that's viewed from the side. In the night sky, sometimes if it's very dark, you can see the side view of our galaxy, and that's what you'd be seeing as viewed on edge. You'd be looking kind of across the side. So where is the Milky Way? This is a simulation of what we think, the universe kind of looks like and where things are all spread out. And you can kind of see where we are. We're in something called the Laniakea supercluster. It's about 100,000 galaxies, about 500 million light years across. So what else is out there? Well, we got black holes. We think at the center of our galaxy there is a black hole. They're black because the gravity is so high that not even light can get out. That's pretty strong. It actually can pull light. Nebula. A nebula, or nebulae, is a region of dust, hydrogen, and helium where stars often form. Now, we also know there's a character from Marvel called Nebula, but that's not the one we're talking about. The other pictures are different nebula, and they are where stars are basically forming. Pulsars are kind of a weird thing. They're rapidly spinning very, very, very fast. So this big, massive star is spinning really fast, and it's giving off kind of a pulse. And we can actually detect that coming from space. Quasars are huge. They are the galactic nucleus with a supermassive black hole emitting a lot of energy. So you can see a couple different pictures of those. And those are images that we have kind of modified the color on so we could see that energy coming out from the black hole. Comets. We see comets every once in a while. There's a couple famous ones that go around, like Hale-Bopp or Halley's Comet. It's a ball of ice and dust that forms a tail when it nears the sun. And it starts to emit this tail. The tail, part of the tail always points away from the sun. So no matter where the comet is, you can always tell kind of where it is because the tail is pointing away from the sun, regardless of the direction it's going. Supernova. A supernova is when a star that's at least 10 times the size of ours explodes. That's a massive explosion. And then what's left is either a neutron star, or possibly a black hole, or just complete destruction of the star. It just gets blown apart, and there's nothing left. So is there anything else out there? Well, there's some other interesting things. There are colliding galaxies. Those are galaxies that are running into each other. Sometimes we see one star actually consuming another star because they're close to each other, and the one with more gravity pulls the other one apart. There are also white dwarfs and neutron stars, and there's lots of other planets that we've seen out there. And maybe, just maybe, there's other life. So to wrap things up, what type of galaxy is the Milky Way? So if you go back a few slides, you'll see what type it is. What are some other objects out in space? So what are some of the other things that were listed afterwards that we can see out there? And there are a lot of things. There are even things that we didn't talk about, like asteroids and meteoroids, big chunks of rock flying around out there. And that will be the last wrap-up question.